saying is there. Okay. Can you see the slides? Is it too light? All right, let me see if I can fix the... Ooh, is that better? Right on. Looks good on the camera as well. Ah! All right, let's try this. Can you hear me? Yeah? Okay, good. Hey! So how are we? Yeah? We're on the right class. I can't believe it's a new semester already. I'm just not ready for this. But we have a beautiful room. It's a law school room, one of the best rooms on campus. Isn't that amazing? Usually they put us in the basement somewhere in the site building, which is quite disgusting. But this is great. It's like a moot court. And every time someone comes late, we make them do push-ups. No? All right. All right, so let's begin. I'm Professor Dionandan. Again, there are many sections of this class, A, B, C, D, and E. And sometimes people get confused. This is C. So if you're in the wrong place, now's the time to get up and conspicuously leave or point and stare and make fun of you. Okay, excellent. Right, so like I said, the lectures are Wednesdays and Fridays, and you're responsible for what is spoken in this class, whether or not it appears on the slides, because I don't write everything on the slides, and the slides are, for the most part, taken directly from the textbook. So some of the other stuff that I say, that's your opportunity to write down wisdom and interpretation. Oh. I have theme music. That's great. Okay, excellent. As I said, there's lots of sections of 2381. We try to cover the same thing, but often we don't. So feel free to coordinate with people from other sections if you like, but be aware the exams are different, the assignments are different. They're not the same class, even though the skills, we hope, we try to coordinate, we try to harmonize, we hope the skills would be similar. And this is your book. It is Statistics and Data Analysis for Nursing by Pollitt. A lot of us use this book. It's ridiculously expensive. I'm sorry. It's like, by the way, these slides were created on Google Documents and doesn't translate well to Microsoft, as you see. So in the future, I'll do them on Microsoft. So for today, though, we're going to have some things that don't quite line up, and the color scheme is entirely wrong. I'm not defective that way. It's the program. Okay, so the textbook, brand new, is like $100. I'm so sorry, I hate that price. You can probably get a used one somewhere. A lot of students sell them on Facebook, on the HSS group. Go on there. I see an ad every day popping up. And you can probably get it on Kijiji. You can probably even get it at the library if you look carefully. Wink, wink, nudge, nudge. Right? I didn't say that. Oh, it's on record. No. So in this class, you are going to be evaluated in 4 ways. You have 2 assignments, 2 data analysis assignments, and we'll talk more about that in coming lectures. One of them, I believe, is already on the website, and you'll have time in the laboratories to work on that. We'll talk about the laboratories in a second. And you have an exam, and midterm exam and a final exam, both of which are multiple choice. And I know you're sick of multiple choice. I'm sick of multiple choice. We're all sick of multiple choice. But the class size being what it is, that's pretty much the only way we can get this done in good time. And people usually in this class find the midterm to be fairly easy and the final to be fairly challenging. I'll see if I can switch that around this year, but probably not. So keep that in mind. But in general, those are the dates. Your first assignment is due October 10, the second November 21st, and so forth and so forth and so forth. Right. I do not take attendance. As I said, the lab sessions are mandatory, but attendance isn't taken there either, and no assignments that you do there are to be marked. So you do the math, right? If you really feel that you don't want to go there, no one's forcing you to go. However, in my experience, the people that go to the labs and do the assignments end up doing better in the course as a whole. So take advantage of the opportunity. I see the lab time as an opportunity to get that little bit of extra context, to try out the skills that I hope I'll be giving you, and also to be exposed to the software, which is the future of all of this. Without understanding statistical software, really you can't get much done as a scientist. So that's your opportunity to develop some skills, and it's there. So I think all the labs are on Mondays. And your TA is him is Fariborz Fazili, who's amazing. He's an MD from another country, so he's doing his master's here in our program. He's really well, really skilled. He was going to be here today, but he had an appointment. He'll be on Friday to say hello to you. And he is your first point of contact. I'm a busy guy. I'm happy to talk to you anytime about anything, but when involving class stuff, go to him first. If he can't solve your problem, then we deal with me, because I'm hard to get a hold of. Okay, so the lab, oh, look at that. Look at that font change there. That's Google. Thank you, Google Documents. I meant to do that. No, I didn't. And yeah, I think it's an MNT 141. Oh, stop abusing me. All right, so I think it's MNT 141. I could be wrong. Does anyone know for sure where the lab is? No? All right, so try there first. If not, then freak out. Okay, so, and they're all on Mondays. And I think their groups are like 10 or 20 people per lab group. It's a big class, about 200 or so. That sounds about right. I'm going to be giving Fadibor's lab assignments for you to do. And again, they're just for the lab. They're not to be marked. They're for your own erudition, your own education as you struggle with some of these things. You can also use the lab time to work on the homework and also on your 2 data analysis assignments. But what I don't want it to be is a time wasted on other stuff. Okay, go there to learn statistics. You've paid so much money for tuition. I mean, so many crazy amounts of dollars. You know that, right? So get something out of it. And one of the important things you can get out of undergraduate education is analytical skills, particularly statistical skills. These are one of the few skill sets that you can apply anywhere in the world in almost any job description. So be good at this, and it opens doors for you. So take advantage. Yeah. Okay, as I said, the exams are multiple choice, and the final is not cumulative. That means after the midterm, you can forget all that and start fresh. No, don't forget all of it. It's part of who you are. It's part of your identity. Absorb all the material, but you don't have to study it for the final. Okay. I said 2 assignments that are not group work. It's individual assignments, and you can do them by computer or by hand, whatever you prefer. One of them would be pretty hard to do by hand. It's that guy at the window staring at us. He walked away. No one else saw him? Am I seeing things? Am I seeing faces? Curious. Okay. Like I said, you can contact me about pretty much anything. I'm kind of hard to get a hold of, so contact the TA first. I don't maintain regular office hours. Email me for an appointment. Okay. Like I said, I don't require attendance. Pay attention. Blah, 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 blah. Don't negotiate marks either. This is a weird thing around undergrads. The professor, I deserve more marks. No, I don't. It's right or wrong. You got it wrong. Move on. Okay. So, yeah, screw that. Okay. That should be lined up. It isn't. So how many of you had taken a statistics class before? See some hands. Just a few. Okay, good. It's okay. You don't have to know anything. We're starting from scratch here. And nobody likes statistics. Okay, a couple of people like statistics. We call them strange people. Right? I don't like statistics, and I have a PhD in biostatistics. I don't like it. I don't understand it. However, that doesn't mean you can't use it. It's a therapy session. Let's share our pain. I never liked it. I took my very first stats class actually in my PhD program. Like, but you know, today in my work, I hire statisticians to do the work that I need to be done. However, I know enough that I can oversee what they do. That's the plan. Are we in the right class? Okay, good. That's because there's this other law class with the same number. It'd be really weird if you're looking for law, and I'm not laying it down. Yeah. Okay, so what does this tell us about the fact that no one likes statistics? It tells us that it's hard, but it doesn't have to be hard. Okay, it's just a series of tools. I don't expect you to be experts in statistics after this class. I don't expect you to be able to derive things from first principles or to be strong in mathematics necessarily. What I expect you to be able to do really is to identify the type of data that is presented to you and to maybe select the appropriate statistical test, apply it, and to interpret it. That's all. That's what most of us do. Right? So I'm happy if at the end of this, at the very least, you're not afraid of statistics, so that as your career progresses, you can add to your skill sets. That's our goal. Our goal is not to be scared, right? Accessible goals. Yay. Keep your goals achievable. So as I mentioned, I try to broadcast some of the lectures. Right? Hey, everybody. No one's logged on right now. But don't rely on it. Sometimes the system crashes, sometimes the audio's poor, sometimes I forget. So do not consider this an online class. Come. Except on Friday, November 14th. On November 14th, I won't be here. So on November 14th, we're teaching the class entirely via YouTube. How exciting is that? So you can be elsewhere. This class will be available to you. You can still come here, sit down with your computers. You can stay home, do it if you want. But I'll be teaching it somewhere with a computer here. Will I be wearing pants? Only I know. It's your job to guess. And so I did this once before with my other class. It was kind of fun. People tweet me their questions if there's an issue going on. But it's pretty cool. So just on that day, because I'll be out of town. All right, so I'll send more details. And by the way, like I said, the links to the broadcast are on the Blackboard website. They're also on my personal website, which is dionandon.com. So there you can always see the streaming links. Okay. If you understand statistics, and by the way, even though this class is called quantitative methods, it's statistics. That's what we're talking about here, right? If you're not doing quantitative methods, you're doing qualitative methods. That's the other half of the health research paradigm. And the quantitative portion of it is doing something with sampling, doing something with counting, doing something with probability. That's statistics. If you don't really if you understand statistics, then you understand something about the fundamental characteristics of the universe. How wonderful is that? How profound is that? It's not just counting stuff, it's understanding the language of reality. Because more and more we learn about the universe, we learn that in fact things are distributions of probabilities. Things aren't things, things are probabilities. That's the magic of quantum mechanics, and we're all quantum beings. So the more we learn about how this is done, the closer you are with the fabric of reality. Are you excited now? Yes, no? Okay, someone nodded. Yeah, okay. The other thing, if you don't end up being a health scientist, if you go on and do something else, which is fine, knowing a little bit about statistics empowers you as a citizen. If you understand how a number was arrived at, you understand where the biases were underlying how that number was arrived at. So oftentimes in the media they'll report a certain statistic. This percentage of people believe that such and such. I want you to have the skills to question that number and say, what assumptions were made underlying the derivation of that number, such that you can more appropriately and accurately assess the validity and quality of that information. Be a better person, be a better citizen, be a more empowered citizen. That's the other part of this. So if you came in here a little bit put off by having to do statistics, now you can think about it as a life skills moment. Okay, statistics, where does it come from? Believe it or not, it comes from the census. What kind of census? Hundreds of years ago, in the 1700s, the word comes from accounts of the state, statistics. So the government in England actually would send people out to count how many sheep you have, how many kids you have. I'm not sure why those two are related. You must have 2.4 sheep per child, I don't know. But the accounts of the state were statistics. So population data goes back centuries before that. There's always been a need to find a way to estimate the qualities of a population, to make decisions. And that's the other key pillar of doing quantitative analysis, is we're doing this to empower us to make decisions, to make interpretations. A lot of times, grad students, for example, will do an analysis and say, well, the p-value was this, therefore it's significant. You learn what that means later on, by the way, and then finish it there. That's not where you finish it. You finish it with, therefore, we believe this has a relationship with that, or this doesn't have a relationship with this. What is the meaning here? What are we trying to do? What are we trying to prove or disprove? It goes back to interpretation. At the end of the day, we're always trying to interpret something to find some meaning in the world. Now, in the last couple hundred years, there have been dramatic changes, in my opinion, in statistics. In the past 50 years in particular, dramatic changes arising from computer technologies. We can do amazing things. On my phone has more computing power than the entire Apollo program that put men on the moon. It's amazing what we can do now. Cloud computing has changed everything. The fact that we can put a supercomputer in the airwaves means that we can do cheap multiprocessor computing instantaneously, almost. When I was an undergrad, I had a project that required my professor to pay for a few minutes of access for me to the Cray supercomputer at U of T. So the Cray supercomputer was the world's fastest computer back in the 80s. And it was kept in a cryogenically sealed compartment, a room maybe 4 times as big as this, and only specialists were allowed in with white robes. And I got the Fortran program, and it cost like a couple $1,000 for me to get 15 minutes of time on it. Now that same power you can get on the Amazon.com cloud. They actually have supercomputing time, cost you pennies to do the same thing. So dramatic changes have been made to allow us to do more incredibly complicated computations. You've heard of big data? Ever heard the term big data? Well, you should. Look at big data. Big data is a corporate term now that describes, among other things, our ability to link enormous databases like your school records with your hospital records, with your SIN number, with your medical records, with your immigration records, and derive acute, very subtle and precise amounts of wisdom about you as an individual. It's scary in many ways. It's empowering in other ways. Right? So big data is what corporations now use to figure out exactly you need to buy a new waterbed in 2 weeks. We know that for sure. We'll target advertising to you right away. So this is revolutionizing how we do everything. And you're at the cusp of a very exciting time. If you want to make this part of your career, now's the time to sort of start investing in the right skills. So anyway, I got ahead of myself there. Revolutions have been happening. And we'll show, as I present you with some of the statistical tests, where some came about historically, the context of them. One of them, for example, one of the most common statistical tests came about when the statistician for the Guinness Beer Company needed a way to figure out how to measure the quality of beer. He invented what's called the t-test today. It's amazing. So you never know how these things will arise. And every couple of years, new developments are arising all the time. This is an evolving science, statistics. What's relevant today won't be relevant tomorrow. It's really quite fascinating, to me anyway. Now, I'm an epidemiologist. Who knows what that is? What is it? Get some numbers up in the end. I'm putting that in my card from now on. I get some numbers up in the end. yeah, that's more or less it. So we look at the determinants of health. So population characteristics to determine what probable associations are with health outcomes. So a big part of that is statistics. That's the bludgeon that we use to crank through data to get insights into healthcare. Right, so increasingly that's becoming one of the larger and larger pillars of health care around the world. Thus, statistics and our ability to process numbers, particularly in partnership with this revolution of computing, is a big part of that. So as you're choosing your career paths, keep some of these things in mind. Keep in mind where the winds are blowing. It does this on its own. I don't know. You guys are so dry today. No one's saying anything. Come on, wake me up a bit. All right. What is statistics? Whatever. It's numbers. It's a way of manipulating numbers. I got the definition here. Collecting mathematical methods, organizing, summarizing. It's just using numbers to interpret relationships. That's the way I would look at it. Is there a difference between math and statistics? What do you think?
Yes.
What is the difference?
Math is straight numbers. Statistics, you have charts and stuff.
You have charts and stuff.
Yeah. Graph.
Interesting.
You use the data for something.
Okay, that's a good way of looking at it, the application. There isn't a clear distinction in my mind, but I'm glad you're thinking about it that way. So in math, we do use graphs and stuff, and applied mathematics is differential equations and things like that. It does happen. It's unclear. So the example I have here is the weights of members of a 2000 U.S. men's Olympic rowing team. So that's the math. These are the numbers. They're distributed this way. The statistics would be interpreting what that means. It tells us that more men are heavy. So we have an interpretation. That might be a way of looking at it. How about data versus information? Have you heard this distinction before? So here are 3 numbers, 50, 52, and 56. Those are data. They're just numbers. They have no context. I collect data. They become information when I apply context to it. Those happen to be the ages of Barack Obama, Stephen Harper, and Nicolas Sarkozy 2 years ago when I first taught this class. Now they're 2 years older than that. I didn't update the slides. All right, so numbers are relevant without context, data versus information. Statistics allows us to get information. What's measurement? Well, measurement is when we apply a quantity to a quality. If I ask you how old you are and you say 25, what is the quality that I'm asking? It's a nuanced philosophical question. If I ask you how old you are, you're not going to say yes. Sorry, how much? How much? Possibly, possibly. Or the length of time you have been on this planet, really, the duration of time. I'm not asking how many years, how many weeks, how many months. I said, how old are you? You answer in years because that's what your reflex tells you to do. So the quantity you applied was 25. It has context and information around it. The quality is your presence on this planet. Maybe I'm trying to figure out, are you old enough to drink, old enough to drive, whatever it might be. There's always a background to it. So whenever we apply a quantity, we're actually losing a bit of the nuance. We've lost a bit of the quality. So keep that in mind. Whenever we interpret these numbers, sure, we're getting how the numbers relate to each other, but it's supposed to tell a story that eventually reflects a quality. What's your gender? Female. Well, gender versus sex, right? There's that thing going on too, right? Am I asking about your biology, about your lived experience? Am I asking about how you think about yourself, whatever it might be? So these things are value-laden too. It's not ever as cut and dry as you might think. A lot of people, when we talk about statistics, tell me they like it because it's black and white, it's cut and dry, it's numbers. Numbers don't lie. Okay, but numbers represent something, and the things they represent have value associated with them. And the numbers that we've chosen to represent that value have woven into that process assumptions. Right? Okay. Got some strange looks coming at me. Hopefully be clear in a bit. Okay. Again, this slide is supposed to be a little more aligned. On Google it was very aligned. Somehow it's lost all this. And it's supposed to be animated. So they'd be flying in right now, but I've lost the animation. It's pretty exciting. I'd ask you, what the first thing is, and then the answer would pop up. But here you get answer and question all at once. So hey, the lecture's ruined. Okay. So the definition of a variable. So there are three different ways of asking yourself what a variable is. So we can say it's a value that changes depending on the scope of a problem. That's a mathematical kind of way of looking at it. We can say it's a logical set of attributes, such as the variable of age, variable of gender, and that's a research kind of question. I'm going to collect this variable from a research question, right? For the math problem, it's this variable divided by that variable. And lastly, a symbolic name given to some quantity. That's a computing kind of thing, right? So in this formula, in this computer program, A is equal to this, whatever it might be. So the word can mean different things at different times. Even in this class, we're going to move around that little spectrum of definitions for variable. And here's how I look at it. So in math, it'll be an X, research, age is variable, computers, a string, it might be. That's horrible how that looks. See if I can move this around a bit. Back up. That's better. Okay. Okay. So we can focus on just one variable. The example I have here is the average age of students in this class. Okay, so the variable there is age. That's a research kind of approach. We can try to describe relationships between variables. So is the average age of women different than the average age of men? What are the two variables there? In the second case, yep. Nope. There are two variables in that bottom sentence. Yep. Age and sex, exactly. Okay, so those are the relationships we're looking at between the variable of age and the variable of sex or gender, whatever you want to call it. Okay, that's a subtle distinction that you have to sort of get through your brain as computational requirements arise, because sometimes, depending upon the number of variables, you choose different kinds of tests. Or if I ask you, I need to, I'm your employer, I need to know the relationship between this and this, and you've got to figure out how many variables are in that question in order to choose the right approach. Okay. Remember in math class, we wrote like a relationship between two variables as a function, f of x equals that, whatever that is. You know, remember that thing? It probably freaks out some of you. F of x is just y. You know? So something we do to x gives us the function called x. Okay, in this case, maybe it's maximum heart rate if you're working out. So the maximum heart rate you should aim for in your workout is maximum is this 210 minus your age. That gives you your heart, so something like that. In math, we have names for those two quantities: dependent variable and independent variable. So as a review from all of you, the dependent variable is the thing that depends on the other variable. The independent variable is the thing that is free to be what it wants. This is my symbol for free to be what it wants. Okay? So think about it this way. If I'm trying to measure maximum heart rate based upon something I do to age. Age can be anything, so it's independent. I'm doing something to age to get my maximum heart rate. So maximum heart rate is dependent on whatever I do to age. Dependent variable, independent variable. Okay, by convention, we put the independent, the dependent on the left and the independent on the right. There's no reason for that, really. It's by convention. That's in math. In epidemiology, or in other kinds of population sciences, we call the dependent variable the outcome, and the independent variable is the exposure. So the exposure could be smoking, and the outcome could be lung cancer. So whether or not you smoke, that's independent. That can be yes or no, you can do what you want. But whether or not you get lung cancer, that's dependent on whether or not you smoke. The outcome is dependent on the exposure. So different terminology means the same thing depending on the context. And the words can be used interchangeably in various textbooks. Here you go. Cancer rate equals 210 minus smoking rate, as an example. Okay. There are two flavors, two broad flavors of variables, I call them. The first is continuous, and the second is categorical. Categorical is also called discrete. So a continuous variable are things that flow, numbers that flow. Like picture them as having no distinct value at any given time. Age, how old are you? I'm 25. I'm 25 in a month. I'm 25 a month in a day. 25 a month in a day in 2 minutes. 25 a month in a day, 2 minutes in a second. It can, the granularity can increase as much as I want. That's a continuous variable. There's no strong lines between different variables. A categorical variable has strong lines between them. So continuous are things like age, height, distance, temperature. If there's stuff in between the values, it's continuous. A categorical variable or discrete variable is age group or gender. You can be male or female, or sometimes something else, but nothing in between. Or a better example is your province of birth. You can be born either Ontario or BC, but not both, and nothing in between. Well, yes, the things in between, but nothing. Yeah, you know what I'm getting at, right? So, categorical versus continuous. Now, when you've got continuous or discrete variables, they can have different numbers of categories. If we're talking about the province in which you're born, you can have up to 10 variables, 10 provinces you can be born in. If you're talking about your sex, traditionally you can have 2 categories. If you're talking about what year you're in, you can have 4. First year, second year, third year, fourth year. Okay? If you've got 2, then we say it's a dichotomous variable because there are 2 levels to it. So the classical dichotomous variable is sex, male or female. Leave aside issues of transgenderism for the moment. Okay? So to dichotomize something is to take something that had either more than 2 variables or was continuous and make it into 2 variables, 2 levels rather. Excuse my clumsiness there. 1 variable, 2 levels. Here's an example. Let's say I get all of your ages, 23, 24, 25, 26, whatever it might be. That's, what kind of variable is that? That's correct, continuous variable, precisely. But I decide, you know what, I only care about the ones who are over 23 versus the ones that are 23 and under. So I'm going to dichotomize that variable and say, if you're over 23, then you get a check mark. If you're under 23 or 23 and under, you don't get a check mark. I've dichotomized that continuous variable. I've made it continuous. Sorry, I made it categorical. Why do I want to do that? Why would I ever want to take a beautiful continuous variable and make it dichotomous or categorical? Yeah?
Does it make it easier to analyze instead of the whole thing?
Absolutely. It's easier to analyze. It's easier to understand very often, too. And sometimes, if I get a bunch of people who are 23 and like one guy who's 50, well, then it stops having any meaning there. So I'll always draw a straight line. Either you're 50 or you're not. That kind of thing. Or this is where we go back to the value again. What is it I'm trying to do? Let's say I care about underage drinking. Let's say that's what my study is all about. And I've got a guy at the bar who's asking people as they come in their ages, and he clicks it. Let's say everyone's being honest, right? So I've got this whole splay of 1,000 people at the bar, and I've got all their ages. And I want to figure out, you know, the proportion that are underage. Well, I'll ask him, how many are under 19? Because I don't really care if you're 23 versus 24 versus 25. All I care about is you're 19 or over. That's the value I've added to the number. The number by itself is just a number. The research question adds value, and based upon the research question, I'm going to modify the variable to behave like something else. So I take a continuous variable and I make it dichotomous in this case. Remember, dichotomous is a kind of categorical. They can be trichotomous, they can be other things like that, but we like dichotomous things because a lot of statistics are done easily with 2 levels, as you'll see later on. So, there are different levels of measurement as well. Your textbook is big on this, a few chapters dedicated to this. And they're called nominal, ordinal, interval, and ratio. These are types of variables, you can look at it this way, or types of ways in which we measure things. Have you heard these terms before in your math class at all? Okay, so it'll be new to you. We'll go slowly. So nominal comes from nom. It comes from nom, name. So nominal is the strictest, purest kind of categorical there is. So if I ask you the province you're born in, that's a nominal variable. And the characteristics of a nominal variable are that I really can't do a lot of math with it. I can't ask you what's the average province you were born in. What I can do is count up the number of provinces and say which one's got the most, which province has the most people in this room. I can do a limited amounts of math, not a whole lot. Okay. So an example here, I've got 30 men, all code is 0, 70 women, code is 1, average is 0.7, which means nothing. So if I ask what the average sex is here, 0.7 means nothing. So doing averages doesn't mean a whole lot with nominal variables. Ordinal variables, again, it's in the name. Ord means order. It's ordered. There's rank. Okay? There's rank, and the differences in the rankings don't mean anything. For example, after your midterm, I can say, you got the top score in the class, you got the second top score, you got the third top score. That's great. We know the rank is. We don't know if the difference between him and him was bigger than the difference between him and him. This could have been a huge difference, could have been a tiny difference. We don't know. All we know is he became higher than him and he became higher than him. So ordinal doesn't give us that nuance of the differences. It just tells us who's on top, who's on second, and so forth. Example I have here is we can do a study where we do something to you and you syringe or something. And we're trying to figure out which syringes are least painful. And I ask each of the respondents, on this scale here, tell me 1, 2, or 3. 1 is no pain, 2 is some pain, or 3 is a lot of pain. That's great. So we've got those rankings. I could take the average amount of pain. I get 1.7. That means nothing. It means nothing because we don't know how far between 2 and 3 were versus 1 and 2. So there's not a lot of math I can do with that either. Again, the kind of measurement determines the kinds of things we can do with the number. So the distances are not equal between, and they're not known. Averages don't make sense with ordinal measurements. Next level down, we call interval measurements. Now these two, interval and ratio, are kinds of continuous variables. The first one, nominal, very obviously a categorical variable, very obviously. These last two, interval and ratio, very obviously continuous. Ordinal, you can make an argument that that's continuous or it's categorical. I would tend to say it's categorical. Right. So interval measurement is like this. It's a continuous-ish kind of variable, and the differences between things are assumed to be equal, but there's no rational zero. We make up a zero that doesn't mean anything. The example here is temperature in Fahrenheit. Right? Temperature, what's 0 Fahrenheit? It's like it's pretty cold. It's like minus something Celsius. It doesn't have any real meaning in real life. Height, on the other hand, has zero height means you're on the ground. You can't get negative height, right? So that has rational meaning. But this zero here has no rational meaning. That's the only distinction between the two of them. Interval has no rational zero. Ratio does have a rational zero. To be honest, in real life, I never encounter interval and ratio as terms. This is something just for the textbook, just for the class, because it's a scholarship kind of thing. But in real life, we tend not to really mess around too much. They're continuous variables. So ratio has a rational zero. Age, being 0 age, that means something in real life. Being 0 degrees, well, you can say that's when water boils, whatever. That's a convenient kind of thing. 0 Kelvin, well, that's got, you know, rational meaning because you can't get any colder than 0 Kelvin. It's got a real life connection to it. Again, value has to be connected to the real world. Value is everything. Okay. In terms of what we can do with the numbers, ratio is best, interval is next best, ordinal is next best, and nominal is worst. And I say that in the sense of I get more statistical options the less restrictive the variables are. So continuous variables, I can take averages, I can take means, I can do all kinds of fancy things we'll show you later on. If I ask you what province you're born in, I can't do any of that shit. On the other hand, we can move up the scale. I can take a continuous variable like age and I can make it categorical. We already said that, right? So the guy at the bar, the clicker, I can say make your continuous age variable less than 19 or over 19. I can make age groups out of it. Give me 0 to 12, 13 to 15, 16, and so forth, right? Depending on the question I'm asking. So I can move up the scale from good to worse, but I can't go back. Here's an example. If I give you some data and I tell you, out of my 100 people here, 25% or 25 individuals were under 19 and 75 were 20 or over. Okay, that's interesting. Can you, in any one of those individuals, tell me their age? No, you cannot, because all you know is if they're over 19 or under 19. Whereas if I had their actual age, I could tell you their age and whether or not they're over 19 or under 19. So as I move up that scale, I lose wisdom, I lose information, I lose the ability to do things. And yet, very often in research, we do move up that scale. We do categorize continuous variables for convenience sake. But every time we do so, we lose information. Okay, here's a nifty little slide that summarizes all that stuff. So it shows that for nominal variables, we can classify things. You're born here, you're born there. What can we do? We can count. We can count the number of people who live in the province. For ordinal, right, we know, again, which group you're in, but also how big you are. You got the highest mark, you got the second highest mark. What can we do? We can count them, and we can rank them. For interval, we can do all the great stuff. We can count, rank, add, subtract. We can't divide or multiply, really. Because, well, you try dividing, multiplying Fahrenheit. I'll give you examples later. More complicated. With ratio, you do everything. Okay. So let's move on now to do something else. And yeah, this is still introduction. Isn't it great? This is the introductory lecture. You're learning stuff. How cool is that? Okay. So with statistics, very often what we're trying to do one of two things usually. We're either trying to describe what's going on, or we're trying to estimate what's going on. I can do statistics on this group and say, 25% of you are female. Interesting. Okay, that's interesting. We can do stuff with that later on. But with, if I'm estimating, I use this group to infer information about a bigger group. We'll talk about this later on. So, and that particular dynamic, I'm sampling. And I'm hoping that my sample is representative of the larger group. Let's say you're my sample, and I'm going to use you to figure out what the university is like, because you guys are representative of the university undergraduate population. You aren't really. Okay, most of you are female, most of you are like 23. The university is more diverse than that, you know. So right now, this is not a representative sample, but I'm going to assume that you are. So if this big blue thing is the thing I'm trying to learn about, in this case the university, we call that a reference population. That thing I'm going to refer to. I'm trying to infer information about. The sample is you. I pluck a sample out of the university, you're my sample, I'm going to do things to that sample. That sounds horrible, but yeah, I'm going to do things to that sample, and I'm going to learn about the university. Okay? So let's say I compute the average number of women in this class, and let's say it's 70% female. I use that information to figure out what is the average number of women in the university, and I apply statistics, some techniques that we'll look at later on, to make that inference. The danger, of course, is that I've chosen unrepresentatively. So here's, I've reached into my bag of stuff and I've pulled out something orange. I thought, hey, the university's orange. But in fact, the university's not orange. It's green. It's all this other stuff. So that's why a big flaw in this process is assuming that my sample represents reality when in fact it doesn't. Now, as we will learn, with the assumptions underlying statistics, often we're assuming that a billion or an infinite number of samples were taken. It gets a little freaky, a little philosophical pretty fast. I'm assuming that a lot of samples were taken and that this one thing that I've chosen is representative of all those samples, not of reality. But I'm getting ahead of myself. Just put that away in the back of your mind. We'll learn more about that in the future. Okay, so there's some terminology when it comes to sampling. The target or reference population is the one I'm trying to talk about, the university in this case. The accessible population is the one I can reach. I can reach undergraduate students in the health sciences program. That's my accessible population, or my study population. The sample is the one I actually get. I can get all the undergrad HSS students. I got you guys. Okay? There's something called a sampling frame also that's not addressed in the textbook. And the sampling frame is part of the accessible population. So let's say my sampling frame, my accessible population is all the HSS undergrads. You know what? Not all HSS undergrads come to class. So I was never going to have access to them anyway. My sampling frame is the ones that come to class. And for the ones that come to class, I chose you guys. That's a little nuance there. So here's a little cascading graphic of what I'm talking about. Let's say I'm generalizing about the United States. That's my reference population, or a theoretical population, you can call it. And who I have access to? The study population. How do I have access to them? Let's say I'm going to do a telephone survey of Americans to ask them, I don't know, which beverage they prefer, Coke or Pepsi. Okay, so I'm trying to generalize about the Americans like to drink Coke. That's what I want to say. So I have access to all the people with phones because I'm going to call them. How am I going to call them? I'm going to get their phone numbers from the phone book. You guys probably don't know what a phone book is. You're so young. We used to have books with people's phone numbers on them. But that's what we're going to use, a phone book. That's my sampling frame. However, not everyone's number is listed in the phone book. So automatically, I've lost some people here. Who's in my, oh, you can't see that. Sorry. And who's in my study? That's my sample. So from the phone book, I choose 100 people at random. That's my sample there. You can probably see the problems already. So the 100 people I choose from the phone book are going to represent all of the USA. Right? So who am I missing? I'm missing people who don't have phones. It's all old people, essentially. All right, so you learn more about this in your research methods class. This is just an introduction to it. And the statistics that we apply to this sample is going to allow us, we think, to infer information and wisdom about that population. That's what we're trying to do. Okay, we'll do more about sampling later. That's my sampling video. I'd be curious. Okay. I mentioned there are two kinds of stats. There's a descriptive stats and inferential stats. So descriptive stats, again, is what I do to my sample. I can talk about the average age of people and so forth. Inferential stats is when I use that information to theorize about a larger population. Another terminology you should be aware of is parameter versus statistic. Okay. You've probably heard the word statistic a lot in lay terminology. In the science of statistics, it means something specific. A statistic is something you learn about your sample. Remember, the sample is you, the people I have access to. So if I take your average age, that's the statistic. If I take the median height, that's the statistic. The parameter is the equivalent information in the large reference population that I'm trying to learn about. So I use the statistic of your average age to estimate the parameter of the average age of the university. Did you get that nuance? It's just a terminology thing. But it's important because we're going to jump back and forth. The parameter always refers to the superpopulation. Example again, the average daily calories consumed by all children in Toronto is a parameter. But the calories consumed by the 300 kids I'm looking at, that's a statistic. One is used to estimate the other. Okay, there are lots of statistical programs available to you these days. Lots and lots and lots of them. We always have discussions in the department over which ones to teach you about. In this program, we rely heavily on SPSS. I don't know what SPSS stands for, but it's the common platform used a lot by social scientists. I use it a lot for smaller analyses, and that's what we'll be using for you. We'll be using that one and also some Excel. So you can get SPSS at home if you want. There's a student version you can get from the bookstore. I think it's like 20 bucks. I don't know. You can get it from less circumspect sources for cheaper, sometimes free. I won't say what those sources are because I'm being recorded. Or just go to our lab where it's there for you. So we have a license. The university, in the lab, you'll have access to SPSS, and we will start the process of introducing you to that piece of software. Has anyone used SPSS before? Okay, we did all of you, that's good. So once you learn one piece of statistical software, the others follow a similar kind of logic. And that's really the trigger here, is like getting over that, oh, that's what we're doing. Okay, now it all makes sense to me. And SPSS uses what's called a GUI, a graphical user interface. So it's essentially point and click. You have data, I'll pull down this menu and do this to it. Or you can use a programming version where you program the steps. We won't be using the programming version. That's like more advanced, just pointing and clicking. And if that doesn't intimidate you too much, then you may want to consider in your future career looking at other programs like SAS or S or Statistica or R, things like that. All these words that mean nothing to you right now that maybe will mean something to you in the future. When you look over this video 20 years from now and say, well, okay. Oh, look at that. That was the last thing. It says Tuesday. It's not Tuesday. It's Monday. Yes, there are labs on Monday. It should be Friday. Friday. Next class Friday, right? Okay. There will be labs on Monday, and I'm trying to get together the assignments for it. And Fabi Boris will be here as well, so you can meet him. Any questions about the course or anything I've said so far? You guys are so silent. Makes me wonder. Yes?
Are the labs every Monday?
I don't know. I think they're every Monday. Fabi Boris will know. Yes? Yes. Okay, here's the thing about the labs, too. Even though they are mandatory, if you can't make them, you can't make one or two, it's not a big deal. Just catch up elsewhere. I mean, again, I'm not marking what's in the lab. It's for your own erudition. If you feel confident enough, so be it. I'm not going to give you a hard time if you miss a few of them. Is there a question over here? I saw a hand. I guess the question was answered. Yes?
Is that computing program only available on the computers in the lab or like also like the library?
They probably have them on many computers on campus. No more questions? All right, we'll see you on Friday.